Quiz 2 answers. Okay. Thanks, Dan. Mr. Dueck, this one was tougher. Good. Good. This is using lots of free body diagrams and friction. Number 1, a 5 kilogram object is pulled at a constant speed. I'd probably mentally underline that phrase. By a horizontal 12 Newton force as shown in the diagram below. What's the coefficient of friction? This is a job for a good free body diagram. Although since they gave me the picture chi, I'm just going to label this picture instead. I'm going to say gravity down. Yep, much like gravity there. Normal force up, I think the same size. Here is the applied force, and I think friction is that way. Who's winning? Trick question. What did I underline? You know what? It's a tie. It's really going to be this. Winner minus loser equals 0. Because A is 0 because it's a constant speed. In fact, you know what? For Pete's sakes, it's really a tie. Well, the applied force is 12. Friction is mu times the normal force. And in this question, you know what they're asking me to find? What's mu? I don't know what's mu with you. They're asking me to find the coefficient of friction, which I guess is going to be 12 divided by the normal force. I don't know the normal force. Oh, but look, 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 look. I know another force the same size as the normal force. Going to be 12 divided by mg. By the way, common mistake I see, a lot of kids, they go, oh, normal force is mg, and they go 12 divided by g. No, 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 g is not a force. G is an acceleration. It's got to be divided by mass times acceleration. It's got to be divided by mass times 9.8. It's got to be divided by 12, 5 times 9.8. That's roughly 12 over 60, which is roughly 0.2. Is the answer A, 0.24? By the way, why would I probably not pick D? A coefficient of friction bigger than 1? That's like crazy sticky glue. I don't think that would be moving at a constant speed. I mean, it's possible, but you need a huge force to be moving something at a constant speed over something that was stickier than Velcro, right? Apparently 2 marks, sorry, all or nothing. Well, you know what? I will say this. If you got the wrong answer, but you wrote that, I'll give you 1 mark out of 2. 2, a free-falling object experiences the forces of air resistance. I think we have gravity down. I think we have air resistance slowing it down. I think winning is gravity. I think losing is air resistance, and I think that equals ma. In fact, to me, that's so important. If I saw that, I'd give you 1 whole mark. Anthony, what's this question asking me to find? How would I get the acceleration by itself? I think so. It's going to be mg minus f air all over m. Let's see. 0.62 times 9.8 minus 1.4 all divided by 0.62. Don't know if I can do that one in my head. Well, nah. Bracket 0.62 times 9.8 minus 1.4, close bracket, all divided by 0.62, and I'm going to 7.5? 7.5419. I'll go to 2 sig figs, 7.5 units. It's an acceleration. So I would go like this. Oh, color didn't change, Mr. Dueck. 1 mark if I saw the main equation, half mark if I saw A by itself, and a half mark for the answer. And I hope what you notice here, Darian, is I really don't care as much about the answer as I do about the process. I figure if I can get you through the process, the answers kind of take care of themselves. I'm kind of assuming in grade 11 most of you can type in your calculator. Yes?
Isn't it negative because it's free falling?
You know what? I'd take that. I specifically didn't say whether I wanted a vector or a scalar, whether I wanted magnitude or not. Traditionally in the forces unit, because we're kind of ignoring direction, because I technically in this question let down be positive, actually technically I would argue with you and I would say, according to my work, I let down be positive and it should be positive, but yeah, I wouldn't be fussy. Good point. Number 3. They want me to find net force is always just MA. That's it. So this should be really easy. Mass is going to be 1,200. A is, You know what, Emma? Although this question said find the net force, you know what I'm going to spend most of my time finding? Acceleration. Yeah. So let's go over to the right-hand side and let's see what we can list here. I'm going to write down A equals don't know. Hey, Emma, what's that? Tell me. What I just underlined. Yeah, what's that? Tell me. Good. How about that? What else do I know? D, you say? Okay, I can find A from that because I got 3 things to find the fourth. The VF squared equals VI squared plus 2AD. Or if I get the A by itself, A equals, what's the equation getting the A by itself there? Uh-oh. Yeah. Why didn't you include the minus VI squared? Oh, it's 0. Nice. So this is going to be 15 squared all over 2 times 85. Looks like the acceleration is 1.3235. I'll carry a few extra sig figs. I'll go 1.3235. Because this is not my final answer. My final answer is going to go in here. $1,200 times 1.3235. I'll use the actual value stored in my calculator. You get 1588 point that? Yeah, technically I should probably go to 2 sig figs, so I'll say 1,600 newtons, but I'll take 1588. Is it an 8 or not? Yeah, 8. In terms of part marks, let's see, this is worth 2 marks. I'd probably give you a half mark if I saw that. A half mark for the answer. I'd probably give you a half mark if I saw A equals VF squared minus VI squared all over 2D. And a half mark for the answer. Number 4. A block, initially at rest, is pulled 16 meters across the floor by a 56 Newton force. If the coefficient of friction is 0.24, what's its final speed at the end of the 16 meters? Okay. Hey, Kyle, what's this question asking me to find? Which one? Hey, what else do I know? Do I know VI? Oh, at rest. What else do I know? What else do I need? Yeah, time. Sorry? Even though this question says find VF, guess what I'm going to spend most of my time finding? Do you ever have deja vu? Do you ever have deja vu? Do you ever have deja vu? Okay, the lame joke. So to find acceleration, I'm going to use forces. All right. What are the forces acting on this box here? Get the obvious one. Gravity down. Normal force up. There's the applied force of 56 newtons. and there's some friction going that way. I think I would argue that the applied force is winning, that friction is losing, and that equals MA. I would argue that the applied force is 56, friction is mu times the normal force, that equals, and you know what? I would argue to get the A by itself, I'm going to divide by M. Do I know mu? Check. Oh, I don't know the normal force. Oh, but look. I don't know the force is the same size as a normal force. Which force is the same size as a normal force? Got to be mg this time. So, I think I can go like this. 56 minus mu, 0.24, m, 12, g, 9.8, all over 12, bracket 56 minus 0.24 times 12 times 9.8 all over 12. 2.31466, that there. I'll write down 2.315, but I'll keep this on my calculator. Is that right? Which means that can go there. And I can now say VF squared equals VI squared plus 2AD. Although VI is 0. And this gives me VF squared. How do I get rid of a squared? Oh, hey, I can do that. VF is going to be the square root of 2AD. VF is going to be the square root of 2.315 D16. 2 times that number times 16 equals square root. And I get 8.6 even, just about. So if you got that, that gets you 3 out of 3. Did I say 3? Otherwise, I would probably go something like this. 1, 2, yeah, I'd probably go half mark if I saw that, half mark if I saw that, half mark for the numbers, half mark for the acceleration, half mark for seeing that, and a half mark for the answer. But if you got the right answer, 3 out of 3. Turn the page, you guys all say? Sure, that sounds right. Oh, you know what? I sense from you folks that I made a mistake on this question. That drawing is so good, I should have signed it. That's a good point. I should have. Okay, there it is. Because that's about as close as I'll ever come to drawing actual art for me. A cross-country skier is moving horizontally over packed snow. Coefficient of friction between the snow and the skis is 0.11. The skier can exert 110 newtons of force through her ski poles. What's her acceleration? Okay. What are the forces acting on this skier? Get the obvious ones. I think a normal force up. I think there's an applied force of 110 newtons. And friction and slowing her down. By the way, that 110 newtons actually isn't her ski poles, because which way do you push with the ski poles? Backwards. So what's pushing you forwards? I mean, it's definitely, I think it's a Newton's third law react. I think it's the like you push against the snow pushes you forwards. I phrased this question carefully. You'll notice I didn't say the ski poles exert a force of 110 newtons forwards. I just said, hey, if the skier can push on their poles with 110 newtons. So it's a nice little Newton's third law thinking that has to go on. Having said all that, who's winning? Who's losing? And that equals ma. And they want me to find the acceleration. I think the acceleration is going to be the applied force minus mu times the normal force, all divided by m. Do I know mu? 0.11. Do I know the normal force? I don't know the normal force. Oh, but look. I know another force the same size as the normal force. So I think I can go like this. Applied minus mu mg all over m. I think the acceleration is going to be 110 minus 0.11, 47, 9.8, all over 47. I'm hoping they 110 minus 0.11 times 47 times 9.8 divided by 47. Do you get an acceleration of 1.2624? How many sig figs, Mr. Dueck? 2. 1.26 or 1.3, and it's an acceleration meters per second squared. Now, if you got that right, of course, 3 out of 3. Otherwise, 1, 2, 3, 4, 5. Yeah, I'd probably go something like this. Half mark, half mark, half mark, half mark, 1 mark for the answer. No, I don't like that, Mr. Dueck. The process is more important than the answer. Half mark for the answer, 1 mark for getting the tug of war right. That's better. Last one. Hello. That's probably important. A wood block, a box, sits on the floor with a coefficient of friction of blah, blah, blah. What force is required to make the box, to move it across a steady speed? You know what? I think this is a job for a good free body diagram. Gravity down. Yoink. Normal force up. I think the applied force is pushing it forward, and it's a steady speed. I think friction is the same size as the applied force. What's this question asking me to find? I think it's asking me to find the applied force. I don't know the applied force. Oh, but look. I know another force the same size as the applied force. Which one? Friction. In fact, when I do my tug of war, it's a tie, and I would end up with that. And then I would say, friction is what times what? Why, Mr. Dueck, clever person, friction is mu times the normal force. Oh, you are such clever people. Except I don't know the normal force. Oh, but look. I know the force is the same size as the normal force. What? Mg. It's going to be 0.32, 20 times 9.8. What force would you need to keep this guy going at a constant speed? 0.32 times 20 times 9.8. 62.72. 62.7 or 63, and it's a force. Newtons. If you get that right, 3 out of 3. Otherwise, you know what? This time I might even give you 1 mark for the free body diagram, and then half mark, half mark, half mark, half mark for the answer. I think that works. Could you be so kind as to give yourself a nice, clear score out of, count 'em, 15? Last day we worked on many body mass problems, and Shaq, you were away. Here's what we said. Look, if you got more than 1 mass, screen is still frozen. Thank you. Unfreeze the screen. If you have more than 1 mass The trick is pretend that you don't have more than one mass. Label all of the forces on everything. We dispensed with, you write this down later, I just want you to watch. We dispensed with the idea of a free body diagram because we had multiple masses. It was easier just to label the forces right on the mass, which technically isn't a free body diagram, but still just as useful. And we said what your equation is going to be is decide vertically everything's balanced, horizontally what's winning this. Walk down the entire rope, writing all of your forces as winners and losers. But since you've looked at more than one mass, you better have more than one mass over here, the mass of both times A. Then we branched off, ladies and gentlemen, we looked at this little device that we called an Atwood machine, which was essentially like an elevator with a counterweight. And we said pause here, work on quiz, finish lesson 4, because some of you still had not. Example 2. It says this. In the diagram below, assume that mass 2 is bigger than mass 1. You know what? Let's put some numbers on here. Pick a mass for mass 2. 10 kilograms? Let's put a little 10 kilograms on mass 2. Pick a mass for mass 1 such that mass 1 is smaller than mass 2. 7 kilograms. Okay. The instruction says A, write force equations. B, solve for the acceleration. C, interpret the equation for the acceleration. We're going to actually add D, find tension. Okay. And what we're pretending, what we're imagining is everything's in a nice straight line with gravity pulling one way and gravity pulling the other way, with the weight one way. Remember, weight is mg, and the weight the other way. Hey, what are the forces acting on M1? Get the obvious one. What else? Is M1 in free fall? No. Oh, what's it attached to? String or a rope? What do we call that force? Is it touching the ground? No normal force then. What about mass 2? What are the forces acting on it? Get the obvious one. I'll call that M2G. What else? And our argument last day was because the rope is the same length of rope, the same piece of rope, the same actual physical rope, the tensions must be identical. You can't pull with 5 newtons on one end of a rope and only feel 2 newtons on the other end of the rope. It's a Newton's third law, forces come in pairs. Shouldn't what be the other way around? Shouldn't the second tension? You've used the word it. First of all, use the word it and other one. Too many pronouns, not enough nouns. And I think you just figured it out. Well then, Darian, my friend, who's winning? Who's winning, folks? If you have a 7 kilogram on the left and a 10 kilogram on the right, which way is this system accelerating? Which way is the 10 accelerating, up or down? Down. So who's winning? Which way is the 10 accelerating? Down. Who's winning? Which one? There's 2. Can you read me the actual equation thing there that I wrote? The expression. M2G. Scene 1, act 1, take 2, and action. Who's winning? M2G. Which means this, Atla, for our equation, anything that ends up when it gets to the right-hand side pointing down is going to be winner plus. Anything that ends up pointing up on the left-hand side is going to be loser minus. Sorry, that was about the force, not you. Darian, what did you say? Who's winning? Now, let's walk down the entire length of rope. I run into this force here, tension. Winner or loser? Must be. We've just decided down on the right is winner, so this must be a loser. Now, when going along the rope, you might be tempted to call the left-hand tension a loser because it's pointing up, but follow it, follow it, follow it, follow it, follow it. When it gets to the right-hand side, which way will it actually end up pointing?
Down.
Winner. This M1G, you might be tempted to call it a winner because it's pointing down like the other M2G, but if you follow it, follow it, follow it, when it gets to this side, which way will it end up pointing? Loser. Did I include forces from both masses? Then I better include both masses. You could write mass both or M1 plus M2, same thing. That's the answer to part A. Part A said write a force equation. Ta-da! Why am I relaxed? Oh, I'm losing tension. I love it when I lose tension, when the tension just falls away. This is like a vacation in a physics equation. Hey, what's B asking us? I've scrolled down. What was part B asking us to find, Margareta? Oh, how would I get the A by itself?
Divide by M1.
No. In fact, I would argue these equations, compared to last unit, are tougher to set up, but easier to solve at the end than the last unit. Last unit, you had to do a fair bit of equation manipulation. It was a little more plug and chug to get the equation. Here it's the other way around. So if I hear you correctly, and I think I do, you're saying, hey, Dueck, A is going to be M2G minus M1G divided by M1 plus M2. Well, let's keep going. M2, 10. G, 9.8 minus M1, 7. G, 9.8, all divided by 10 plus 7, which I did in my head and said was 17. Yeah? Good. What's the acceleration? Oh, by the way, there is a small built-in error check here. What can't the acceleration ever be bigger than in this particular situation because we're on the Earth? It can't be bigger than 9.8 because if we cut the ropes, it'd be 9.8. The ropes aren't cut. It's got to be smaller than 9.8, which means if you get an answer bigger than 9.8, you probably got something wrong in your calculator. Speaking of calculator, you need to know how to type this in, so try typing this in. Is there more than one number on the top? Better use brackets. Do you get an acceleration of, pretty small, I think. Yeah, 1.73. Yeah? Units, it's an acceleration. Okay? So, that's the, oh, come here. That's the answer to part B, find the acceleration. What's part C ask us to do? It says interpret. Well, did we get a positive or a negative answer here? Positive. That means we guessed the winner right. The 10 is moving down, the 7 is moving up. Every once in a while, especially in Physics 12, you'll have questions that are so complicated that you really don't know who the winner is, and so you make an educated guess. And if you get a negative acceleration, you know what that means? You guessed wrong. Although it's a fairly easy fix, because usually all that means is all of your winners were actually losers, and all of your losers were actually winners, which I teach my kids in grade 12. Don't rewrite the question. Just change every plus sign to a minus sign, every minus sign to the plus sign, and double check to make sure you have friction going the right way, because that's the one that's a tricky one, but we're not doing that much friction this year. So it's doable. So part C says interpret. This means the 10 kilogram is accelerating down, and the 7 kilogram mass is accelerating up. Why? Because I got a positive answer. I guessed right. That's also a built-in error check. Trev, what was the last thing it asked me to find? The one that I added? Tension. tension. I can find tension by looking at one mass. Which one? Doesn't matter. Although, if you're clever, you'll pick the one in which tension is a winner. So look carefully at those two masses. In which mass, mass 1 or mass 2, is tension the winner? Ben?
Mass 1.
Mass 1. I'm going to write an equation for mass 1. Who's winning? We're looking at mass 1. I don't see an M2G on mass 1. I said I'm going to write an equation just for mass 1. So looking just at mass 1, ignoring mass 2. Who's winning?
Tension.
Who's losing?
M1G.
If I want to find tension, it's going to look like this. And that's going to equal not the mass of both times A, because this time we chose to only focus on mass 1. So it's going to be M1A. How would I get the tension but self? Rob? Which one, minus or plus? That's why I picked tension to be the winner, because I figured I'll be plussing and I'm better at plussing than minusing. Plus what over? So you're telling me, and you're right, tension is going to be M1A plus M1G? Double check with me, Rob. Do I know G? 9.8. Do I know mass 1? 7. Do I know A? That's why I had to do B before I could get down to this part. Yeah, okay, this is plug and chug now. It's going to be 7 times, what was the acceleration? 1.73 plus 7 times 9.8. Yoink. Do you get 80.7? What if instead you hadn't used mass 1? What if you chose to use mass 2? What would the equation be if you used mass 2? Who's winning? M2G. Who's losing? Tension. Okay, your equation would look a little different. It would go like this. M2G minus tension equals, and it would be M2A, because you're only looking at mass 2. This one, Rob, to get tension by itself would be plus it over the tension and minus M2A over at the same time. I think would be the easiest way to do that. And when you do that, you'll get tension equals M2G minus M2A. You'll get tension equals 10 times 9.8 minus 10 times 1.73. And lo and behold, $1.72941. I also get 80.7. So it doesn't matter which one you pick, Reed. Choose wisely. And it's a force, so it's newtons. Example 3 says, find the acceleration of these systems. Let's go like this. Yoink. Let's do the first one. Is there more than one mass? Then let's just label the forces right on the diagram. What are the forces acting on that 3.5? Get the obvious one. Really?
Gravity.
And since there's more than one mass, I'll call it M1G. Let's change colors. What else? Tension pointing up. What else? Nothing. Hey, what are the forces acting on this 5.7? Get the obvious one.
Gravity.
What else? Who's winning? Who's losing? Anything that points up when it gets to the right-hand side. What's my equation going to be like? winner, minus loser. Keep going. Oh, I run into another tension. Loser, pointing up. Oh, wait a minute, though. When it goes across the pulley to the other side, which way does it end up pointing? Winner. I run into M1G. Loser, it's pointing down. Oh, wait a minute. When it goes around to the other side, it ends up pointing down, up. Loser. I do have forces from both. So both masses. Help me out. I lose tension.
How long do you stay
Pardon me? How long will I stay there?
there? How long will you stay there? if you're upset?
30 seconds or so. I'm pretty tired. You'll never know. Hey, what did this question ask me to find? Well, talk to me. Hi. Any advice? Yeah, Mr. Dueck, lose the nerd shirts. No, I mean about this.
Put in the numbers for
No. Let's get the A by itself. Right? How would I get the A by itself, Darian, my friend?
divide by.
Yeah, let's do that. Let's do that. We get A equals M2G minus M1G divided by M1 plus M2. Now I'll put in numbers. M2. M1. All over M1 and M2, although I wrote M2 plus M1, but still. Can I do this in my head? Let's see how good I am. The top is going to be 1.2 times 9.8 ish. It's going to be 0.9. No. Yoink. 2.34347, 2.34? Yeah? That? What's the weird thing about this right-hand one? Why is this right-hand one a little strange?
You get it?
Hey, what's weird about this second diagram?
You get it?
It has variables. I didn't give you the mass. So you got a couple options. If I was a nerd, you can actually solve this all algebraically, or you could just let the letter M be 2, in which case this mass here would be 2 kilograms, and the left-hand mass would be 6 kilograms. We're good to go. I'm going to pass on that, and instead I'm going to say, let's try, ooh, this one here. Okay? So here's a lovely little Atwood machine. Mass 1 apparently is 12.5 kilograms. Mass 2 is apparently 24.6 kilograms. And it wants us to find the acceleration and the chord tension. All right. Suggestions. Let's label the forces. Good call. Let's start with mass 1. What are the forces acting on mass 1, Valoria? Get the obvious one. I totally agree. I'll call it M1G since there's more than one mass. By the way, what's the fancy schmancy word for Mg? Begins with the letter W. No, tell me now.
Wait.
No, tell me now. Wait. No, tell me now. Okay. But please, when I use the term weight, W-E-I-G-H-T, please make sure that's the synonym for mg. I'll use them interchangeably. Is mass 1 in free fall? Nope. That must mean there's a force. Oh, there's a string attached. What do we call that? Tension. Mass 2, what are the forces acting on it? M2G. Tension. You have to get the questions off somebody else. I don't know which ones I'll assign, but most of them in the homework. Who's winning? How do you know? Oh, it told me which one's heavier. M2's heavier, so M2G's winning, which means now I've decided anything that ends up pointing down on the right, winner plus. Anything that ends up pointing up on the right, winner, loser negative. So I think my equation's going to look like this. Winner. Now what? Walk along the rope. Minus tension. Tension. Plus tension. Jeez. M1 and M2 times A. Oh, I lose tension. I like that. It's like a day on the beach in Hawaii. Losing tension. What did this question ask me to find?
Acceleration.
Oh, so? More specific. How?
Divide the bracket with M1 with M2.
So you're saying, hey, Mr. Dueck, the acceleration is going to be M2G minus M1G all over that? Okay. You're saying, hey, Mr. Dueck, it's going to be 24.6 times 9.8 minus 12.5 times 9.8 all over whatever 12.5 plus 24.6 is. Is there more than one number on the top? I'm thinking brackets. Is there more than one number on the bottom? Yeah, I'm thinking brackets as well. I think I'm going to go like this. Bracket 24.6 times 9.8 minus 12.5 times 9.8, close bracket, divided by bracket 12.5 plus 24.6. That looks right. Do you get 3.1962264? 3.2? 3.20 if I go to 3 sig figs, which it looks like I should based on my data. 3.20. 3.20 what? Are we done, or did it want us to find anything else? Oh, tension. Which mass is going to be easier to use to find tension, mass 1 or mass 2? I think mass 1. Why? Because tension's the winner in mass 1. So in your mind, or even with your finger, cover up mass 2. What are the forces acting on mass 1? Get the obvious one. M1G. What else? Minus tension pointing in the opposite direction. And that's going to equal... Sorry. And you did that totally wrong. I should have asked the wrong question. Who's winning in mass 1, Dane? I just said what are the forces. Who's winning in mass 1? I apologize, folks. Who's winning? Who's losing, Gloria? M1G. M1G. Is that going to equal the mass of both times A? Why? Because I'm only looking at one mass. I better only have one mass. Double check. Do I know mass 1? Do I know G? Do I know A? Good to go. I just got to get the tension by itself. M1, 12.5. A, 3.2 plus 12.5. G, 9.8. Now, I wrote 3.2, but if I'm lucky, I still have this stored on my calculator. I do still have this stored on my calculator. It's going to be 12.5 times answer button plus 12.5 times 9.8. Ta-da! 162.45, 162 newtons. Reed, could I have found it using the other mass as well? Yep. It'd be one extra line, but I'm not going to do my double check this time. I'm going to say good enough. Is it one more and we're done? Couple more, two more and we're done. Okay. Hey, why is example 5 different? Looks like the same diagram, Mr. Dueck. I don't know. What are they asking me to find? Oh, they didn't tell me one of the masses. Okay. Suggestions?
Get M2G by itself.
Well before that, suggestions.
Draw a label.
Let's label the forces. What are the forces acting on mass 1? Get the obvious one. I think so. Tension. M2G. Tension. Oh! Yeah. Says because mass 1 is accelerating upwards, can you assume that mass 2 is bigger than mass 1? Yep. In fact, I think what you're really saying is, I think M2G is the winner. I think that's the direction of the acceleration. Winner is going to be anything that points down on the right side. How's that help? This is the reverse of the questions that I've done with you so far. In the previous questions, I gave you all of the data, all of the information, and I said, find acceleration, use that to find the single forces. Here, do you notice they gave you one of the single forces? Which one? Tension. I'm going to use that and a single mass to find acceleration. So instead of starting with both masses, winner minus loser, if everything equals M both, A both, find A, and then use that to find the single masses. I'm going to start out saying, use the single masses to find A, and then use that to find the missing mass. In other words, my children, I'm going to start out looking at M2, because that's the mass that I know. Sorry, I'm going to start out looking at mass 1, because that's the mass that I know. I apologize. Mass 1. Can you write me an equation just for mass 1? Looking at mass 1, who's winning? Who's losing? So we have this. Change colors. We have this. What does that equal? What's going to go on the right-hand side? Why is that so handy? Do I know tension this time? Do I know mass 1? Do I know G? Then I can find A. Not with A winner minus loser both. A winner minus loser 1 mass. How would I get the A by itself? It's going to be 6.5 minus 3.2 times 9.8. I'm terrified I might have made up bad numbers here. All over. Do you get a negative answer when you crunch this? Do you? And this is what happens when I make up numbers. I added this question a couple of weeks ago without crunching it. Not to worry, we can fix this. Yeah. Look up. See where it says tension? Put a 2 in front of the 6. Whoa. That was a little strange. Oh. 26.5. 26.5. Is that going? That's going to be too small. Put a 3 in front of the 6. Good gosh, Dueck. It must be last block of the day. 36.5. 36.5. Let's see if that works, Mr. D. Please give me a positive answer. Please give me a positive answer. Please give me a positive answer. Whew. Sorry. It looks like A is 1.60625. I'll keep the extra sig figs because A is not what they wanted me to find. What did they want me to find? M2. Let's write an equation for mass 2. Who's winning mass 2? M2G. Who's losing mass 2? Equals what? What are we trying to find? Let's get the M2s to one side and the non-M2s to the other side. I'm going to plus this to that side. At the same time, I'm going to minus this to this side. I'm going to get this. M2G minus M2A equals tension. Trev, what do I want to find? Mass 2. Trish, what do I want to find? Yeah. Folks, how many mass 2s do you see there? How many would I prefer? 1. It would be wonderful if there was a grade 9 mathematical operation that I could pull out of my back pocket and turn that from 2 yucky masses to 1 single mass. Is there? GCF. Is there an M2 in both terms on the left side? Kai, say yes. I can factor it. I can go like this. Can I not? Oh, and then what? How would I get the M2 by itself? By what?
T.
That, how would I get the M2 by itself? Dane's right, I'm going to divide. By what? The bracket. Math 9. Who knew? Mass 2 is going to be tension over. You can try memorizing that equation, but it varies depending on whether mass 2 is bigger or smaller. Derive it. Don't memorize crap. What did we say tension was? 36.5 after I finally fixed it. All divided by 9.8 minus, I can already see I'm going to need a tiny bit more room. Give me 1 second here. Yeah. 9.8 minus 1.60625. I'm going to use the answer button on my calculator. Is there more than one number in the bottom? Brackets. So it's going to look like this. 36.5 divided by bracket. 9.8 minus, and I can tell you what the math needs to be. 4.45. 4.45 what? It's a mass, kilograms. We're going to finish off this last example tomorrow. I'm going to give you some questions to try. Tomorrow, the plan is this. I think we're going to finish off this lesson, and then for the remainder half hour, we may even go wander back to the basketball games, and I'm going to say finish the homework, or you can work here. I'll give you the option either or, but I'll do it in some kind of supervised, organized way. What can you do right now? I think you're capable, in theory, of being able to do number 1. I think you're capable, in theory, of being able to do number 2. Number 3. Number 4. Number 5. So far, that's all of them. I know. You have to practice this. Number 6. Number 7, I think the acceleration can be done. The trick is, don't treat that as a 12 and a 2. Treat that as one big what? 14. But then it says find the coefficient of friction between the 2 and the 12. That's actually from an old old physics 12 provincial exam nasty question. See if you can figure that second part out. I'll be impressed if you can. Then I have a bunch of Atwood machine questions. I'm just using the same diagram over and over. It says draw a free body diagram for each mass, labeling each force. I really just find it easier to go like this and then label the forces as I go. But you can represent the masses with a dot, if you will. You can try number 8, number 9. Number 10. Now, number 11 is where it starts to ask you to try and find masses. I'm going to say you can try 11 if you figured it out from today's lesson. You can try 12. You can try 13. You can try... Are you assigning all of them, Mr. Dueck? Probably. Number 16, take a look at this. It says nasty question. This is from an old Physics 12 scholarship exam. Again, this is sort of a bonus question, but if you can figure this out, I'll be impressed. This was worth, I think, 10 marks on a provincial exam one year. Okay? You can handle it. I've given you all the tools. This is being clever and stubborn, not actually new stuff. You can also try 17 if you want. That's also an old Physics 12 provincial exam. This is actually kind of like an Atwood machine question, asking you to find mass 2. Actually, you know what? You can do that. Not a bonus. Now, that seems like a lot. I'm going to talk for about 10 minutes tomorrow, and then I'm shutting up. Okay? You can get a start right now.